The Nekemte-Bako Road is a lifeline. It connects two bustling towns in Ethiopia. This vital artery carries farmers, traders, and families. They depend on it for their livelihoods and daily lives. A smooth, reliable road means access to markets, schools, and healthcare. But the Nekemte-Bako Road is far from smooth. It's plagued by potholes, cracks, and crumbling edges. This isn't just an inconvenience, it's a danger to drivers, a drain on the economy, and a barrier to progress. The road is failing, and we need to understand why. The Nekemte-Bako Road was built with the best intentions. It was meant to last, to withstand the heavy traffic and challenging weather conditions. But somewhere along the line, something went wrong. Opened in 2013, it was designed to last a solid 20 years, but by 2014 the problems started popping up like weeds after rain. From rutting and potholes to alligator cracking and more, the road is falling apart and the consequences are serious. We need to get to the bottom of this, to figure out why this vital link is failing and what we can do to fix it. The people who depend on this road deserve answers, and they deserve a road they can rely on. The Nekemte-Bako Road tells a story of neglect and decay. The signs are everywhere, etched into its surface like wrinkles on an aging face. Rutting, those deep grooves worn down by countless tires, snake along the road. Potholes, gaping wounds in the asphalt, threaten to swallow vehicles whole. Cracks, like spiderwebs, spread across the surface, a testament to the road's failing structure. And along the edges, the road crumbles away, eaten away by erosion and neglect. These aren't just cosmetic issues, they're symptoms of a deeper problem. They point to a failure in the road's foundation, a weakness in the very materials used to build it. The road is literally falling apart from the bottom up, and the evidence is clear for all to see. Every crack, every pothole, every rut is a costly reminder that improper materials and poor testing don't just disappear, they resurface. This road was meant to connect communities, to drive progress, but instead it's become a symbol of failure. To understand why the Nekemte-Bako Road is failing, we need to dig deeper to examine the very ground it's built on. Soil testing is the key. It's like taking an X-ray of the road, revealing the hidden flaws that are causing it to crumble. One crucial test is the Atterberg limit, which measures the soil's moisture content at different stages of consistency. This tells us how the soil will behave under varying weather conditions, whether it will shrink, swell, or lose its strength. Then there's gradation, or sieve analysis, which determines the size distribution of particles in the soil sample. This is crucial because well-graded soil with a good mix of particle sizes provides a more stable foundation. Compaction testing measures the soil's density, indicating how well it was compacted during construction. Proper compaction is vital for a strong foundation that can withstand the weight of traffic. Finally, a bearing ratio (CBR) test assesses the soil's strength, specifically its ability to resist deformation under load. This is critical for understanding how well the soil can support the weight of vehicles without collapsing. Using experimental research and purposive sampling, the team collected materials from various layers of the road: asphalt, base course, sub-base, and subgrade. The lab results from the Nekemte-Bako Road paint a grim picture. Various quality tests were carried out, including Atterberg limits, soil classification, compaction test, and more. The soil tests revealed some alarming discrepancies when compared to standard specifications for road construction. The Atterberg limits showed that the soil used in the road's construction has a high plasticity index. This means the soil is highly susceptible to changes in moisture content, expanding and contracting significantly between wet and dry seasons. This constant movement puts stress on the pavement, leading to cracks and potholes. The gradation analysis further revealed that the soil lacks a good distribution of particle sizes. It's poorly graded with an excess of fine particles. This means the soil is prone to water retention, becoming weak and unstable when wet. The compaction tests confirmed our suspicions. The soil was poorly compacted during construction, resulting in a less dense and weaker foundation. This lack of density allows the soil to compress more easily under the weight of vehicles, leading to rutting and further pavement deformation. Finally, the CBR values were significantly lower than the minimum requirement for road construction. This means the soil is simply not strong enough to support the weight of traffic, leading to the observed failures. Well, the culprits were a mix of factors. There was insufficient or even absent side drainage structure, traffic loading beyond what was anticipated, poor gradation of base course and subbase material, and substandard quality of subgrade soil. The study concluded that the road needed urgent routine maintenance to prevent further deterioration and extend its service life. Imagine the cost and inconvenience of frequent repairs compared to the initial investment in proper construction and materials testing.